Hello, my name is Kim Cobb. I'm the director of the Institute at Brown for Environment and Society and professor in Earth, Environmental, and Planetary Sciences here at Brown University. I'm really excited to be talking to you today about climate solutions and to share a little bit about my journey and some of the work that is going on at Brown and many other universities to advance climate solutions. So thanks for this opportunity, and I hope you enjoy the rest of the training episodes. This is a photo of me doing my kind of traditional line of disciplinary work, scuba diving in the very center of the tropical Pacific Ocean with a very large and powerful drill to recover a core of coral that has grown over the last several decades. And that core will allow us to look into the history of past ocean temperature extremes in this very data sparse region to understand how extremes have changed in this region since greenhouse gases started rising and warming, global warming ensued. And then, of course, looking into trends as well of the average ocean temperatures through time. So we can use corals from the very recent reef, and we can use corals further back in time, as I'll share later. The main goal of my research is to reconstruct the extremes related to the El Nino Southern Oscillation. And this is a natural climate phenomenon that occurs every 2 to 7 years. It's born in the tropical Pacific, as you can see here from this map of the Pacific Ocean, which depicts a really large scale and quite dramatic ocean temperature warming from the central to eastern tropical Pacific. And this warming disrupts atmospheric circulation patterns all around the globe from pole to pole. And it causes a spate of climate extremes that range from droughts and wildfires in some places to extreme flooding and mudslides in many others, with profound impacts on both ends of those spectrum for infrastructure, freshwater resources, and of course, the community's livelihoods and food production. And so this is something that is, of course, a huge question in climate research. Is El Nino changing in response to global warming and anthropogenic climate change? And this has been the driving question of my research. And so the white dot in the middle of this slide is showing the research sites that I've been working on over the last 20 years to try to amass enough evidence of past, present El Nino events and records. I started doing this work back in 1997 on my very first cruise, which turned out to be, we didn't know it at the time, but we were sailing into the largest El Nino event of the 20th century. So that was quite an experience and kind of left an indelible mark on me. And I've been really privileged to revisit these sites in following decades over many, many other El Nino events that you can see listed there. And this year is quite exceptional as well. We're expecting a fairly large El Nino event to occur this year in the central to eastern Pacific. It's far too early to tell how that event might evolve. El Ninos are something that we actually need to see in motion before we can actually say if it's going to be a significant event. So our predictive skills are still quite weak, despite all the data that we have over the satellites and buoys across the entire tropical Pacific. It still remains something that's quite difficult for us to predict. So we will know within a few short months how large this event will be. It will grow through December 2023 or January 2024, and then it will begin to decay as all events are pegged to the end of the calendar year for their peak. So stay tuned, and you heard it here first. So really what my research is focused on is not just amassing coral records of El Nino events over the more recent past, the last 100 years to 200 years. Most coral research is focused in that interval and focused on the modern reef materials that are available. But that only takes you back so far, of course, because you have a limit to how large corals can get in coral reef environments today. So to go further back in time, we turn to this archive that I'm picturing here, which is basically storm rubble or these large wave deposits that have rolled these corals off of the modern reef and past reefs and onto the shore across the Line Island chain, which is the island site that I've been working on for 20 years or so. And this is a coral here that's very large. You would not want to be around when this thing got rolled onto the beach. And you can see our team using the very same drill that we use underwater, which is very heavy and cumbersome, as you can see, to drill a coral core from this specimen. We take this material back to the lab. We date it with uranium, thorium, radiometric dating techniques. And in this case, we found out that this coral was about 500 years old. So it provided us about 90 years of continuous monthly resolved information about El Niños and their cool La Nina counterparts dating back 500 years. So prehistoric events, if you will. And when we do enough of these kinds of recovery from enough different kinds of material, we've been able to develop a fairly extensive record spanning the last millennium by piecing together different segments of corals covering different time periods. I'll show you that in a second, as well as push this reconstruction back to the oldest material we've been able to recover, which dates to 7,000 years before present. So looking into a much longer baseline of El Nino and La Nina activity. And so when we're back in the lab, we split the cores open. You can see me holding one of those slabs with one of my former students. And we drill a powder every 1 millimeter, tiny, tiny amount of powder. It goes into that glass vial set one by one that you can see in the foreground. And that rack of samples goes into the mass spectrometer that you can see behind my shoulder. And then what we do is we measure the oxygen isotopic composition of that coral skeleton. We've known for at least 70 years that the oxygen isotopic composition of carbonates is very closely tied to the temperature in which that carbonate was formed, in this case, when the coral laid down that piece of skeleton. And so that really helps us generate a record of El Niños and La Niñas through time. It resolves decadal scale of variability, and it also picks up things like anthropogenic warming trend, as I'll show you in a second. So this is what one of our reconstructions looks like. This is from Christmas Island. We have other island reconstructions, which are greatly similar, but I'm focusing on Christmas Island. It's the southernmost island of the Line Island chain, and something that we've had quite a few samples from. So this is all from the same island to keep things simpler. And what you can see is these different windows of time back through the last millennium. That's a millennium worth of time on the x-axis now. And you can see that in general, you know, there have always been in these records El Niños, which are warm events going towards the up direction on the graph. And there have always been La Nina events down to the cool direction of this graph. As we move into the 20th century, we see that this baseline of ocean warming is quite visible and quite unprecedented. And of note, when we have a large El Nino event like occurred during 2015, 2016, which was the last largest El Nino event, by the way. What we have is an El Nino event that occurs on top of a pretty significant warming trend that's been occurring over many decades in this region. And so that 2015, 2016 El Nino event brought our coral values to their warmest reconstructed temperatures ever recorded in our site. And so obviously we don't need a record like this to help us understand that we're pushing into unprecedented territory with global warming in all regions of the world. But we do need a record like this to try to answer the question of whether El Nino events are actually changing in response to anthropogenic climate change. Why do we need a record like this? Because the instrumental record of climate is just far too short to conclusively answer that question, given that only a handful of large events have occurred over the instrumental record. And so when we amass our entire reconstruction over 7,000 years, and we look at the statistics of past El Nino events versus the last several decades, what we can definitively say from our reconstruction is that there is a statistically significant difference between the El Nino events in the pre-industrial era and those that have occurred in the last 50 years, with the last 50 years events being significantly stronger than before. And so that's one of many lines of evidence that seems to be pointing to an effect of anthropogenic climate change and greenhouse gases that's already having on the characteristics of the El Nino Southern Oscillation as a natural climate cycle that is being perhaps amplified by climate change. Something that, of course, is still remains a subject of intense study across all different kinds of paleoclimate archives, as well as people focused on modern instrumental data and climate models and Earth system models of our climate past, present, and future. So I would say the jury is still out, but more lines of evidence than not do point to this influence. And I think it's something that we will see mature over the next couple of years as we recover better and better data, both from the past as well as even this 2023 event, another kind of pile onto the data set. And every single El Nino event that we have becomes extremely valuable. I want to note that, in fact, if this event turns out to be a very strong event in 2023, as some models predict, it would be the shortest recurrence interval between major El Nino events that has occurred in the instrumental record. So that's just a mere 8 years. And so that's notable, and perhaps one of the will be one of the turning points in us beginning to understand how the statistics of El Nino are changing with climate change from even in the instrumental record. So stay tuned. Really what I wanted to focus on for right now, however, is turning over to understand what is happening to the coral reefs under this pressure from continued ocean warming, superimposed with record-breaking El Nino events. The 2015-2016 El Nino event was, in fact, a record-breaking event. It took the Line Islands to unprecedented temperatures never seen before in the instrumental record of climate. And so we can look at a reef that I was diving on in 2014, and you can see beautiful coral cover, large diversity of different kinds of species of coral there. And you can see on the right what happened after exposure to 10 straight months of coral bleaching and mortality level temperatures. And the reef has been completely decimated on the right. And you can tell because those bright, vibrant colors have given way to a uniform kind of cover of red-brown algae. And as you get close to that, it kind of wafts in the currents. There are very few samples that are visible in this photograph of corals that have lived through this particular heat extreme. And obviously, those are the targets for some of the work that we're doing around coral resilience and the threat of rising ocean temperatures. So they may hold some interesting clues. But for me as a scientist, I had been anticipating a scientific, just an amazing trove of information that we were going to get from so many repeat expeditions across this particular El Nino event that we did. But coming face to face with this destruction and bearing an eyewitness with our scuba diving teams to this level of destruction did change me. It's not something that I could have really understood emotionally until I experienced it. I was experiencing El Nino events on an intellectual level, not really an emotional one. And this really hit home for me, something that really changed me personally and professionally, and spurred me to think about how I could really engage more meaningfully in climate solutions and climate action, both personally and professionally. So I'm going to share a little bit of that journey and how it shaped my research agenda and kind of bring us right up to the frontier of a body of climate research that is emerging as critical to climate science in this century. So first, I just wanted to note that 2016 was not only the warmest year in the Central Pacific, it was not only a largest El Nino event on record by many metrics, but it is also remains to this day the warmest year on record. 2023 may beat 2016 out if we have a large event. Stay tuned. So again, I'm thinking about my career as one separated by this 2016 experience and to extreme death and destruction on the coral reef, and one that was post that, which is focused on more solutions and climate action in my work in a professional and personal life. And in the personal life, I really threw myself into exploring a lower carbon lifestyle. And that was extremely rewarding and fed back on itself in kind of a virtuous cycle. I started biking to work. I still do that for my mental and physical health every day. I stopped flying, which at the time was 85% of my personal carbon footprint. And to me, just such a marker of climate injustice by the global elite that I just can't get on a plane right now, quite frankly. And so that's something that is quite a dramatic change, but somebody of my privilege and historical carbon footprint really should be doing it, in my opinion. Personally, that's been an extremely powerful choice for me. It's the right choice for me. It's something that reflects the reality that aviation is growing faster nationally and internationally than almost any other source of carbon emissions right now. And in fact, we have no viable alternatives. So something to think about. Of course, also on the home front, thinking about composting, solar panels, heat pumps, insulation, the whole gamut. I'm still on that journey, enjoying every minute of it. Professionally, though, I think is where I can say I've really seen the biggest impact over time from this approach. I was called to testify to Congress. It was a deep honor in 2019 about climate impacts and climate solutions and how we could leverage science for solutions. And then just in January, I was appointed by President Biden to the President's Intelligence Advisory Board, a body of Americans who are charged with basically helping understand the framework of national security, its strengths and weaknesses with respect to the intelligence apparatus in the country. And so climate change is a national security threat. It is also a threat to the intelligence machinery as laid out in many Department of Defense reports and is specifically in a 2021 report on intelligence impacts from climate change. So armed with those kinds of information, I'm proud and honored to sit there, learning as I go with my fellow board members, trying to connect these dots between the climate science that I know and understand about our future with what we can do to keep Americans safe, preserve our national security, preserve our economy, get ahead of geopolitical tensions, et cetera, et cetera. So I wanted to spend the last portion of my talk here talking about the emerging landscape for climate injustice as it regards these just incredibly sobering statistics present in the Intergovernmental Panel on Climate Change 6th Assessment Report, Working Group 2, which is the Impacts and Vulnerability Group. And this quote here from the actual report just rings in my head as a clarion call to action for climate scientists. And I personally have kind of taken up the mantle of thinking about how we could leverage our science to reduce these kinds of vulnerabilities going forward. And I'll show you some examples of what that looks like. But basically, already over the last decade, we can see that deaths from climate impacts and climate extremes is 15 times higher in more vulnerable regions than in less vulnerable regions. So as we think about what climate solutions means in the 21st century, this is really the foundation of a climate solutions framework that is addressing these devastating losses, which are only going to get worse going forward. And so I wanted to lift up a project that I started with my collaborator, Dr. Nataki Osborne-Jelks at Spelman College during the pandemic, focused on mitigating extreme heat in urban Atlanta. Across the nation, extreme heat is the leading cause of weather-related deaths in this country, and to the tune of thousands of deaths per year, more than any other extreme death rate combined. And this is a project that was really born of the necessity to think about a proactive approach to managing extreme heat exposure that meets the needs of vulnerable populations today and includes those communities in the research project. Very honored to have a deep partnership with the West Atlanta Watershed Alliance, a decades-old environmental justice-focused organization in Atlanta that is helping us think about what it means to work with underserved communities, what it means to think about how they can bring solutions to the table that in some cases may already be at their fingertips, in some cases need some critical advocacy at the policy levels in the mayor's office or city or county, et cetera. But nonetheless, to include a table where we have those partners and the research team, we have the city and the county partners at the research on the research team, and then a slew of people who are academic experts, ranging from computer scientists to social scientists to health scientists and earth scientists like myself, coming together to think about what is a systems level challenge requiring systems level solutions. Urban Key ATL is the project that came out of that design process, and it is a project that arms community scientists, over about 100 of them, with this temperature sensor that you can see. It's handheld. It talks to your phone via Bluetooth. And as you walk or bike around your environment, it can sample temperatures and send those data sets back to the servers, and we can amass a huge data set, over 3 million points and counting now, of temperature retrieved from the Atlanta area by our community scientists. These are a combination of students and Atlanta residents. And this is the kind of profile that we get. So you can see an east-west transect, somebody's walking there, collecting data every second. And then a north-south transect where there's a biker collecting data every second, moving much faster. And that temperature is not varying very much as they move through a road in that case. But the walker is really capturing quite a distinct difference between their walk meandering through the old growth canopy, in this case, in this little neck of the Atlanta on this one block. And as they merge at the other end, you can see temperatures rebounding to about 7 degrees C higher, or 7 degrees Fahrenheit higher, as they approach those black tops and corners again. And so the goal of the project is really to map hotspots across Atlanta that are, always systemically there, in most days are hotter than their surrounding environments, and then think about what that means for exposure of vulnerable populations and what that means for urban and city planning tools that might be able to help mitigate some of those hotspots and mitigate some of those exposures. Another project that I wanted to talk quickly about is one that's based in Savannah, Georgia, where flooding is an acute problem for many communities on the coast. And it's not just hurricanes anymore. It's blue sky flooding from king tide events. It's wind-driven flooding from the wind blowing in the wrong direction for too long. And this is becoming a everyday challenge to coastal residents and people who are charged with keeping them safe. And so Smart Sea Level Sensors is a project that took root in deep partnership with city and county officials in Savannah and Chatham County, as well as Savannah State University and the Harambe House, which is a decades-old Savannah-based environmental justice organization that we have the honor and privilege of working with as we consider what it means to incorporate the priorities of underserved, vulnerable populations in Savannah to our project team in terms of including them in research questions, research execution, research products, research resourcing, all of those things. So those are the partnership nexus. And at the core of our work is really a Georgia Tech designed sensor that you can see there docked onto a dock. It's about a shoebox size. And it's based on ultrasonic pulse that pulses the ocean surface, and by travel time can help us understand the distance between the sensor and the water level. And every 6 minutes, it sends back a measure of water level at that site. We have about 65 of these deployed across the region, and they're very low cost and they're very accurate. We have learned we done quite a bit of benchmarking with NOAA's gold standard sea level sensors, and we feel very confident about our data to the centimeter or so. So when we work with the community members, we're thinking about applications to emergency planning and response. We're thinking about flagging critical infrastructure like bridges, transportation corridors, hospitals, et cetera. And we're also thinking about longer-term resilience-based projects. So what would it mean to incorporate this kind of information about hyperlocal flood risk into models of this risk going forward, hyperlocal flood risk going forward under a variety of sea level rise scenarios. And so it's through these conversations that are anchored in technology and innovative frameworks that we're actually able to think about intervening in what is an incredibly sticky and complex problem on the coast. But this is a sustained project. It's been 5 years in development already. It's institutionalized down there on the Georgia coast, and it will continue to be a platform for discussion and collaboration and technology development for decades to come. So here at Brown, I've moved from Georgia Tech, so those projects were showcasing some of my work at Georgia Tech. And now I hold a new role at Brown as director of the Institute at Brown for Environment and Society. And we have a new strategic plan that I hope really brings to life this work here at Brown and really spurs it to materialize into partnerships that extend across the entire region and beyond. So we're working with our students, our faculty, our staff, and our many, many external partners to think about what it means to conduct solutions-engaged scholarship here at Brown on the issues of the day, including climate change and environment and sustainability, and also thinking about what it means to build explicitly a framework for community-engaged scholarship, which, to my mind, are deeply intertwined in terms of the mission and goals of this work to really drive real impact and real-world solutions in this critical moment. So we do this through a framework that's laid out in our strategic plan, which is really about research and education, of course, the hallmarks of higher education, but also thinking about where that overlap is with climate action. whether that's for Brown as a campus or for the city of Providence or for a broader region or a climate action opportunity that is far outside of our geographic domain. And we ground all of this work in a framework of justice and equity because, again, we firmly believe here at the Institute of Brown for Environment and Society that advancing this work, advancing solutions that are durable, replicable, and scalable, they must be also equitable. And so this is where these deep partnerships come in. This is where our framework for community engaged work and stakeholder engaged work comes to life. I wanted to highlight one existing project at IBIS that I think has been absolutely transformative thus far, and I'm sure will continue to be so going forward. And that is a project called Breathe Providence that's led by Professor Meredith Hastings here at IBIS. And what she and her team have done is develop and deploy a growing network of relatively low-cost air quality sensors around underserved communities in Providence. Of course, these communities, we already know, have disproportionate exposure to air pollution and contaminants that are already harming the health of children and other vulnerable populations in these regions. So working with community organizations here in Providence to design and deploy and monitor this network of air quality sensors has been an amazing accomplishment thus far. And I know that they have explicit designs to begin to connect these data streams to policy priorities and policy outcomes by collaborating with the city of Providence and, where necessary, the state of Rhode Island and the EPA. So stay tuned for that. I'm very excited about that project. I think it marries research and education. You can see the student team standing there with Meredith there, and this sphere of climate action, in this case, at a much broader region than just Brown's campus. So I wanted to wrap this up, not so much with, I guess, summary statements of what I presented, but just some reminders about where I hope we're going and some of the lessons that I've learned along the way. So I think the top line statement is that this is very likely the most consequential decade in human history, where we will collectively decide how much warming we want to let in to our atmosphere over the next several decades. And of course, how quickly we would like to be able to move into a global cooling mode. Both of those two things, of course, linked. The higher we let temperatures get, the more time we have to bake, and the lower we can keep emissions and the lower we can keep the warming rates, the sooner we can reserve the right to begin global cooling, which could initiate in the second half of this century if we really move aggressively on emissions. So I just want to start with that headline statement. I think it's so critically important to keep that amazing work of the science in the foreground as we think about our own roles in this moment, whether it is in climate science or a related field of research, or whether it is through finance, through law, through communication, through education. All of these are instruments of climate solutions if we can bring the pieces together much more coherently. And that brings us into reality of the last statement here, which is that we need to champion a really inclusive definition of what climate solutions mean. Too often we think about the climate scientists as the people who hold the information and hold the answers. Most often we just hold the information about the problem, by the way. Yet we do know so much. It's packed into the National Climate Assessment here in the United States. It's packed into the Intergovernmental Panel on Climate Change report at the international levels and many other national and regional assessments. So we know so much. We know much, much, much more than we need to know to act. And much of that could be translated right now into real world impacts that can keep people safe today and prepare to keep communities safe and thriving over the next decades of warming. But we also need to recognize that we're facing critical knowledge gaps in applying some of that trove of climate science information to real world action on the ground. And some of those knowledge gaps really reflect the fact that these impacts are going to be local to regional in nature. And that's the scale where, frankly, maybe we don't have enough information just yet. We do need to work with stakeholders on the ground, local data sets, and take a regional framework to understand what's possible in terms of building resilience. What are the priorities for economic wellness through this time, for public health and safety through this time? Those are some of the answers we're going to need, and we're going to need to work together across disciplines within academia and beyond, but also with other sectors, the private sector, the governmental sector, and the NGO sector, to come together and address the systems level challenges with systems level solutions. Some of the projects I've talked about today are really driving towards that kind of framework. And I'm happy to say that the U.S. Global Change Research Program has really outlined exactly that kind of strategy as the way forward for its 10-year strategic plan for charting the path forward for all of climate change research. So that's very exciting. It's a time of heady change in climate research, and it's an honor to be a part of it. It's an honor to be alive in this moment. I hope you feel the same, and I hope you feel inspired to think about your professional journey as one that could be transformative in climate solutions. Thank you so much.